Hello, sixth graders. It's me again, coming to you live from the west side of Little Falls. I hope yesterday's assignment went a little bit better after you watched my help video. Again, if not, please don't hesitate to let me know if I can do one of those problems for you on one of these videos to help you out. Today we are going to continue our study of volume. Now we have been practicing using graduated cylinders, and after our color lab I feel like you guys got a lot of practice with that. Okay, so measuring a liquid volume is pretty straightforward. Another way to measure volume is measuring if you've got an object that has straight sides like this sunglasses box, we can measure the length times the width times the height, and that'll give you the volume of this box. But what about the sunglasses that are inside it? How do we take the volume of something like my fishing glasses that are irregularly shaped? How would we do that? We can't really take length times width times height because there's all of these curves and areas that are void of stuff, right? It doesn't have mass right in here. Okay, and so we are going to use something called the water displacement method today. And I'm going to walk through a couple examples with you. It says to measure liquid volume, use a graduated cylinder. To measure solid volume of a regular shaped object, like this box, you can measure the sides and multiply length times width times height. But how do you find the volume of an object that is solid but does not have measurable sides, like a rock, a bolt, a key, etc.? Okay, so things that are not, do not have straight edges. How do we do that? And this applies to life. When I just remember when my grandma was making cookies. Back in the day, we used something called Crisco. I don't know if you guys are even familiar with Crisco, but in order to measure a cup of Crisco, it was like this greasy gelatinous goo, okay? And you couldn't really measure it in a cup because there was all of these air pockets. And so if we wanted to have a cup of Crisco, we would get one of those big glass measuring cups and we'd fill it a cup of water, and then we'd put Crisco in there until the water went up another cup, and we would know that the difference between those two was 1 cup of Crisco. Just so you know, there are things that we do in real life that we learn in this class. Okay, so right here they give us an example. We've got a rock, and it says here that they've got 50 milliliters of water in this graduated cylinder. You can see that very clearly. It's 50 milliliters of water, and that's what they're starting with. You can start with any volume of liquid, okay? You want to make sure that it is enough water that the object will be completely submerged. In other words, you don't want to start with 50 milliliters of water and then stick a rock in there that's going to stick out halfway up here, okay? You want to make sure that the whole thing is submerged within the water. And then they drop the object into the cylinder and the water level went up because the object displaced the water. It moved it up. And now the graduated cylinder reads 75 milliliters. So very simple math here. They're taking the final volume, subtracting the beginning volume, and the difference is 25 milliliters. Okay, the volume went up to 75 milliliters. They started with 50. And it's the difference between these two, and that difference is 25 milliliters. That means the rock that they were measuring is 25 milliliters. That's the volume of this rock. Okay, let's practice a couple of these. It says, find the volume of the Lego. Okay, well, we are starting right here with, looks like the sides go up to 20, but we know that we measure from where? Go ahead and sing the song. The bottom, the bottom, the bottom of the meniscus. Looks like this is 15, 16, 17, 18, 19 milliliters is what we are beginning with. So we're going to go ahead And we are going to type that in right here. 19 milliliters. Okay, now we've put a Lego inside. And really, you know, you might think of this as something that you could measure the length times width times height, but what about all these little nubbies on top? Those take up space too, right? So we have to include those in there, and that would be very difficult to do with a ruler. Okay, so using this displacement method would be best to get an accurate measurement. Okay, so we put the Lego in, and it went up to 24 milliliters. 24 milliliters. All right, so now all we have to do is subtract. 19 from 24 is 5, right? 19, 20, 21, 22, 23, 24, yeah, 5. 5 milliliters is the volume of the Lego. Okay, here's another one. We've got a graduated cylinder. Ooh, I'm going to have to maybe make this go up a little. Let's see if I can move my face here and make this bigger so I can see, because my eyeballs are old and they can't see very well. So it looks like we've got a volume of, there's 10, 15, 20, 25, 24, 23 milliliters right here. 1, 2, 3, 23 milliliters is the volume of water that we're starting with. 23 milliliters. We put a pen inside the graduated cylinder, and we have 40, 41, 42, 43 milliliters. Okay, we're just subtracting. What's the difference between these two numbers? Think, 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 think. Don't be afraid to use your calculator. 20 milliliters. Oops. Got it? Does that make sense? All right, today what you're going to find is, if we go to the next page, you're going to have the opportunity to do this on your own, and you're going to measure 8 random objects. Mr. Apelia and Joanne was kind enough to get me a big tray of junk. Surprisingly, they were able to find it all around my classroom. And you can just write down right underneath these numbers what it is, what object it is that you are measuring. Okay, so you don't have to go in any particular order. You know, different students are going to be measuring different things. So let's say I choose a marble. Okay, so right underneath this number 1, I would write marble. Okay, on the gray table over by the sink, you'll find that tray of junk. You'll also find 100 milliliter graduated cylinder, and you're going to find some beakers. Remember the difference between a graduated cylinder and a beaker. A beaker looks more like a cup, like a juice cup, right? You're going to fill that up with water. Any amount of water will do. That's just for you to be able to pour water into your graduated cylinder, and then after you're done measuring, dump it back in. Okay, so it's kind of your back and forth container. So you're going to pour in a volume of water. Let's say I start with 50 milliliters. I'm going to drop my marble in and then take another reading. Now, I don't have a graduated cylinder here. I don't have any marbles here, but I'm just going to make up a number. Okay, so let's say it went up to 52. Okay, I'm going to do my math here. I'm going to take 52. I'm going to subtract 50. And I am going to get, I'm going to get a math problem that is taking up too much space is what I'm going to get. I'm going to get 2 milliliters. You get the idea. I can't move this. It's not quite. Oh, yes, I can. There we go. I'm going to get 2 milliliters. Okay. And so my answer over here, I'm going to transfer that over here, 2 milliliters. And it says, be sure to include the unit. That's just good practice to get into. I know that we're using milliliters for all of these, but make sure that you write this down here, okay? Milliliters, 2 milliliters. Okay, and then you're going to go on to the next object. Maybe you get a race car. Okay, you're going to pour a random amount of water into your graduated cylinder, measure it, record that here. Drop the race car in, measure it, record it here, do your subtraction, and tell me what the volume is, remembering to include the unit of milliliters at the end. All right? And you're just going to go through with 8 different objects and carefully and precisely measure them. All right? You can work in a group. That's fine with me, okay? I would like everybody, each individual, to fill out one of these sheets. And there's paper copies of this. And when you are done, I would like for your tables to be wiped off. Grab a paper towel from over by the sink. Make sure your tables are dry. Make sure all the objects are back on the tray. Make sure your graduated cylinders are neatly lined up on that table by the sink. And your beakers are empty and sitting on that table as well. Okay? This is just a nice practice lab to practice taking water displacement volume. All right, and if you have any questions on this, let me know and I can make another video to try to help you out. I hope you're well.